All right, so section 1.2 is observational studies versus designed experiments. Experiments are a little bit more important, and their findings mean a little bit more, so they actually have a whole section to themselves in section 1.6. But 1.2, we're going to decipher between the two and talk a little bit about observational studies. So if you look at the first objective, it's just being able to distinguish between one and the other. So let's look at the definitions and see if that helps us. An observational study measures the value of the response variable without attempting to influence the value of either the response or explanatory variables. That is, in an observational study, the researcher observes the behavior of the individuals in the study without trying to influence the outcome of the study. What's crazy is in observational study, they have bolded two vocab words, response and explanatory variables, without defining them, okay? So your response variable is the variable that you're studying. So this is the variable being studied. And your explanatory variable is the variable that influences the response variable. All right? So the response variable is the variable being studied, and the explanatory variable is the variable that influences that response variable. What does that mean? It means if I'm studying the growth of a sunflower, the growth itself would be the response variable, but what influences the sunflower's growth? We talked about it on Monday. Water, fertilizer, sun, soil. All of those are explanatory variables. They explain the growing. Does that kind of make sense? So explanatory, the root word's explain. It's explaining what's happening. Response, it's getting the response from them, okay? Observational study, what's the root word in observational? Observe. That's exactly what an observational study is. You're just hanging out and recording. You're not trying to convince anyone. You're not manipulating anything. You're just literally watching and then recording what's happening, okay? So you could poll for favorite TV shows. Or count number of black cars. Polling for favorite TV shows or counting the number of black cars in the parking lot. Does anybody have an obvious favorite show, TV show? Anybody willing to say it?
Riverdale.
What was it?
Riverdale.
Riverdale? Oh, I binge watched the first season when I had the flu last semester. Game of Thrones, anyone? Does anybody watch Game of Thrones? Nobody? What? No, there's no like binge watching favorite. What do you like? Friends, yes, some of that old school stuff like Grey's Anatomy, that kind of thing. So if I just went around the room and asked you guys, and you just told me your answers, am I trying to influence you at all? No. I would just write down your answer, so that would be an observational study. Same thing with the cars. Am I trying to convince the black cars to come in and every other car to stay out? No. I'm just counting how many black cars there are, okay? So there's no manipulating. You're honestly just observing, okay? Let's look at the next definition for a designed experiment. If a researcher assigns the individuals in a study to a certain group, intentionally changes the value of the explanatory variables, and then records the value of the response variable for each group, the researcher is conducting a designed experiment. So this is manipulating. If you are manipulating or changing things, you are having control. And that's going to be a designed experiment. Okay? I think the obvious example, those Grey's Anatomy fans, is that placebo versus a drug, right? Does everybody know what a placebo is? We actually define it later, but it's just that fake drug, okay? So if I'm giving you guys all medicine that's supposed to help your head, not everybody should get that medicine. I need a control group. So some of you would actually get the headache medicine, some of you would get a sugar pill, and you wouldn't know the difference. Those that watch Grey's Anatomy, remember when they were testing for Alzheimer's, and they had that, one was fake, one was real, and it was that whole idea, they're manipulating who gets what and so forth, all right? The next example is taste testing for preference. Now you might think, how is taste testing manipulating me? You're just letting me taste and say what I like the best. Well, that's one thing. If I went around the room and said, okay, how many of you guys, what's your favorite soda, what's your favorite soda, what's your favorite soda, that would be an observational study. But I have 4 sodas that you have to taste test, and I get to decide what 4 sodas those are, what order I give them to you, how much you get to drink. That is manipulating. And so that's going to be a design experiment, because I get to control what you're drinking and what order you get it and so forth, all right? And then down here it just has a little asterisk that says, observational studies are very useful tools for determining whether there's a relation between 2 variables, but it actually requires a design experiment to isolate the cause of the relation. So basically, they're important. Observational studies are important, but they're kind of that anecdotal evidence. You're kind of just observing, there's not a lot of data. But if you observe something and you think you're catching on to something, you might potentially look more into it and do an actual experiment and actually get real results, okay? So these are all kind of confusing. Confounding, guys, in a study occurs when the effects of 2 or more explanatory variables are not separated. Remember, your explanatory variables are things that are affecting your response variable. Therefore, any relation that may exist between an explanatory variable and the response variable may be due to some other variable or variables not accounted for. I'm going to use my sunflower growth again. Say I'm studying how well a sunflower grows, but I want to test my fertilizer, okay? I have thousands of different variables that are affecting my growth. So if I don't purposely somehow pull my fertilizer to the side or try to make the sun, rain, soil all the same, I'd have a bunch of confounding going on, right? Okay, if I have my sunflower there and there and there and there, this one might be grew really well, not because of the fertilizer, because of its location and so forth. So you have to try to manipulate as much as possible to keep everything that you're not studying the same, so that your one thing you're studying, the fertilizer, could really be the difference, all right? One type of an issue when confounding happens is that favorite vocab word again. Remember that lurking variable? Here's the definition again. It is an explanatory variable that was not considered in your study, but could really affect the value of the response variable, okay? In addition, lurking variables are typically related to the explanatory variables considered in the study. So again, lurking variables, sun, water, soil, all those are something that I need to consider when I'm testing for fertilizer, okay? A confounding variable is an explanatory variable that was considered in a study whose effect cannot be distinguished from a second. So basically, we know what confounding is. So if it's a variable, it becomes a confounding. These are just go hand in hand, guys. Confounding is the verb, it's the action. But the actual variable that's doing the confounding is called the confounding variable, right? So like the sun, soil, water, those would be confounding variables. What I did, and let's see if I still have it. I try to pull in as much information from real life experiences as I can. So I found this in a recent Parents magazine, okay, where it was an experiment about fast food. Do you guys eat fast food? We eat probably more fast food than we probably should. Okay, let's read this real quick. It's this yellow one. Another reason to go slow. It says, eating a lot of fast food may be detrimental to a child's brain, a recent study found. Kids who eat fast food 4 or more times a week when they were in the 5th grade scored lower on math, reading, and science tests in 8th grade than those kids who hadn't eaten fast food as frequently. Many items at fast food restaurants don't provide the nutrients that promote learning processes needed to be successful at school, says lead researcher Kelly Pertl, assistant professor of the Ohio State University. Also, high fat and high sugar meals have been shown to reduce memory and attention. So it's a good study. They're trying to get information to the parents. Hint, hint, try not to eat fast food, right? But this has a lot of lurking variables that are happening, okay? So she's trying to say if you eat fast food a lot, you're not going to do as well as everybody else. What are some lurking variables that are going to affect how well a child scores in math, reading, and science in the 8th grade, other than just the fact that they ate fast food? How much they studied, right? So study techniques. What else? Sleep? Attendance, okay? And then let's start linking it, okay? Those kids that did poorly and supposedly they ate fast food, what other things could be going on in their life or their parents' life that would connect having to eat fast food and doing poorly on test? Isn't fast food usually a time issue, right? When do we get fast food? We're hurrying home, we don't have time to make dinner. But if you don't have time to make dinner, what else don't you have time for? Studying, helping your kid out, whatever it may be. Is that okay? Not to sound negative, but laziness, right? Maybe a parent's too lazy to make a meal, so what do? Fast food. But if they're too lazy to make a meal for their kid, what else might they be lazy for? Helping them study, right? Or even income. I know that's kind of stereotyping, but fast food is so cheap. Like, if you want to eat healthy, it's expensive, but fast food is so cheap. And sometimes those that have lower incomes have lower school attendance and so forth like that. And so then sometimes they don't test as well because they just aren't getting the services that they need through their school. So there's a lot of little things you have to think about. Could it be due to the fact that fast food's not the greatest? Also taking in fact, that was a 3-year age gap there. Did you notice that? It was 5th grade to 8th grade. A lot of things can happen to a kid in 3 years, not just the fact that they're eating fast food, okay? Let's look at these next 2 examples. You probably already did them without me. We just want to make sure we can tell the difference between an observational study and an experiment. So I gave you 2 examples down here. One is one and one is the other. Let's read this first one. A personnel director at a large company studied the eating habits of the company's employees. The director noted whether an employee brought their own lunch to work, ate at the company cafeteria, or went out to eat for lunch. The goal of the study was to improve the company cafeteria. This type of data collection would be considered what? An observational study or a designed experiment? Observational study. Did he try to manipulate them at all? No, he probably just kind of sat by the front door / cafeteria and just kept track of how many of those went in, bought lunch, brought their lunch, or left, right? So this is going to be observational study. And this was a perfect thing. The goal of the study was to improve the company cafeteria. Once he observed that a lot of people weren't buying food, maybe he could look into why, all right? The second one, process of elimination, but let's make sure we can tell. A scientist was studying the effects of a mosquito pesticide on birds. She captured 10 birds of each of 3 different species, so really 30 birds, in the area, sprayed them with pesticide in the area, or sprayed them with pesticide and in the area not sprayed with pesticide. So she collected some that had been in this pesticide area and some that hadn't been. She then measured their weight, the number of eggs in the nest, the beak length, and the quality was recorded. This type of data was what? Considered an observational study or a designed experiment? Usually the more complicated it is, it's a designed experiment. There was a lot going on. She decided that there'd be mosquito pesticide in this chunk and not this chunk. How many she's going to capture from each, measure all this stuff, okay? So this is a designed experiment. And your little footnote there, experiment, make sure I can spell, is the key difference is control, right? If you have control, that's an experiment. If you're just observing, that's an observational study. All right? So, observational studies aren't used as frequently and aren't as important, but there are 3 different types. So we're going to learn the 3 types. The first one is called cross-sectional studies, and I want you to write present right here. And that means present like right now, not like happy birthday, here's a present, okay? That's present. It's a point in time, right? Cross-sectional studies are when you're doing it right now, all right? So it says, these are observational studies that collect information about individuals at a specific point in time or over a very short period of time. So this is kind of gets lengthy. I'm going to write it down. They say, you look at a group of people. So we'll look at group. determine smokers versus non-smokers. Okay, we're going to look at a group of people. We're going to determine smokers versus non-smokers and compare lung cancer rate. I haven't told you this, but I'm going to forewarn you now. This stats class is kind of like a Debbie Downer class. You will not get over how many examples and problems deal with cancer, deaths, shootings, stabbings, like a lot of stuff. And I think the reason being is because they can collect a lot of data on it and talk about stats. They're never talking about how many unicorns there are in the world or anything like that. So just kind of a fair warning, if it is one of these, it's not me choosing them, it just happens to be what a majority of the problems are in the book, okay? So right now, say you're my study, all right? And I'll look at your group and I'll say, well, how many of you smoke, how many of you don't? And then I'll look at all the non-smokers and say, okay, how many of you non-smokers have cancer? And then how many of you smokers have cancer? Have I manipulated anything? No, I just asked you guys stuff, and it's right now. How many smoke? How many have lung cancer? Yes or no, okay? So cross-sectional is like you're cutting in half right now, and we're going to ask you now. Go ahead and flip over to top of page 6. So we had present, but now we have past. All right? Case control studies are retrospective. Retro, we all know what retro means, in the past, right? So they're retrospective. What it does is it requires the individuals to look back in time or for us to research your old records. And then individuals that have certain characteristics are matched with those that do not. So I'm still going to use that lung cancer example. Let me put it into different words, okay? So lung cancer paired with no lung cancer. And then individuals are asked how much they smoke. So lung cancer is paired with non-lung cancer patients. Then I say, okay, do you smoke now or did you smoke for how long? That kind of thing. I kind of get your history, and then I compare incident rates. So in this one, I know a little bit more about you, so that's why I compare you with a cancer or a non-lung cancer patient. But then we have to look back in time. It's not do you smoke now, it's just have you ever smoked? And if you did, for how much, how long, how many? And so it's definitely looking back where instead of just saying right now do you smoke, do you have cancer, yes or no? Okay? So we're looking back in the past. Last but not least, we had past, we had present. So guess what cohort studies are? The future. And sometimes you guys might have heard of the word cohort. It's like a group of people that kind of go to the same classes together. You kind of just have this group. And it says a group of individuals are identified to participate. So that's what the cohort is. And then over a period of time, characteristics about the individuals are recorded where some are exposed to certain factors, maybe smoking, right? And others will not. At the end of the study, the value of the response variable was recorded. Cohort studies are prospective. Mean we're looking into the future. Okay? So what that means is right now, I would say you guys are my cohort. Okay? Go on and live your life for a couple years. Smoke, don't smoke, I don't care, right? And then come back to me in 3 years and report back to me how many of you guys smoked, how many of you didn't, do you have lung cancer, do you not? Okay? So we're looking in the future. I don't know anything right now. I just am telling you right now. These usually are the best because you have the most control as the researcher, right? Like I can say, hey, I want you to smoke but only 5 cigarettes a day. Or, you know, you can start kind of limiting things or decide what they should be avoiding. Where the past ones, case control and cross-sectional, it's kind of just happening then or in the past, you don't have as much control. All right? Last but not least, guys, we have this last definition. Existing sources of data and census data. This is called a census. Let's put that in, census. So that's C-E-N-S-U-S. Has anybody heard of a census before? Usually you hear about it in like a political science or a government class or something like that. What a census is, it's a list of all the individuals in a population with certain characteristics. Has anyone lived at a house, or have your parents received something in the mail where asked, how many people live in your house, how many are under 18, how many are male, how many are female, what's your ethnicity, all that kind of stuff, how much do you make? That's called a census, and it's just a way for people to get an idea of who lives in their community. And the reason why, you're like, why are we talking about this in stats? Why do we need to know about census? Is because if we want to collect data about something, say you want to study the average amount Alton or Godfrey families make, you might not have to take a sample. You might be able to go to the library, pull up the census, and find the average. And so, have you guys heard of the term, why reinvent the wheel? Anybody? The wheel's a great invention, right? So why try to make a new one? The census, it's already done it for you. So why make things harder, all right? And so this is just a way you might want to write. It says you're able to obtain information you may want by simply researching, okay? And without having to do a study, which is nice. The U.S. Census does actually determine the number of representatives you have if anyone's into government. That's how they decide how many representatives are in the House of Representatives. All right, are there any questions about section 1.2? I'm going to stop this.